In this video, we're going to look at what's new in the latest release of RAMP. So I've clicked on the release notes here, and this applies to RAMP version 2020-12-15. And you can see there's a list of 23 new additions that have been, or modifications that have been made to RAMP since the previous release, which was 2020-12-01. I'm going to talk through some of the main changes that have been made, but you can review this entire list yourselves to see all of the things that have been done to RAMP. So the first major change was the ability for RAMP to now support rasters that exceed 2 GB in size. Previously, there was an artificial limit imposed by the .NET framework that RAMP is built on top of. But now that has been overcome, and you can use rasters that are considerably larger than 2 GB. The next changes have been made to the raster rendering properties. So I'm using an example here to show you. So if I go to Edit Rendering Properties, you'll notice now the first thing is that the Rendering Properties dialog has memorized or remembers the settings that I have previously applied to the raster. And so that's one of the new features. The other one is if I now click on the color ramp here, I have a visual display of all the color ramps that are available to RAMP, and all the color palettes that are available to RAMP. And you'll also notice that there are a lot more color palettes in here. In fact, there are 107 color palettes now in RAMP. I'm going to just choose a new color palette for the sake of example. And the other thing I want to talk about is the fact that now with the rendering method user-defined split points, previously you had to manually pick the split points, but now you can define the split points by value or by number of standard deviations from the mean. So in this example, I'm going to pick 0.5, 0.7, and 1 standard deviation from the mean. And you will see that RAMP has now added those split points to the histogram. Whilst we're on the topic of rendering, there's been a few new methods that have been added to the rendering processor. So you'll notice that the generate color map methods have been added. These allow you to choose a color palette and a specific raster, and then define either linear, split points, or equalized to map the color palette to an output color map. This is important when you want to programmatically generate color maps based on a specific raster. An additional method in the alpha blend to images method here allows you to essentially take two rasters, render them using a color map that you've previously defined, and then blend the two resultant images together such that the one image on the top has a transparency over the top of an image on the bottom. So this is known as alpha blending. I'm going to quickly show you how this works. So with my two images here, I have a bathymetric data set, and I'm going to re-render it because I'm not entirely happy with this color scheme. I'll choose a nice color scheme here. Let's choose this one. Let's tell it to equalize. Okay, I have a nice rendering of my bathymetric data set here. And I've also generated a hillshade for that data set. And I want to blend these two images together using the new blend processor. So firstly, I need to save out their color maps. So I'll do the first one, and I can save the color map here. Let's put it in sample data, and I will call this color map. Sorry, let me try that again. Sample data, calling it color map. And I'm going to do the same with this hillshade. I'm going to save the color map. and we'll call it hillshade. Save that color map. Okay, now using that rendering method for blending, I'm going to say that the bottom image that I want to render is the hillshade, and the color map that I want to use is the hillshade color map. And I want the blend to be 128. That's a 50% transparency because the values range from 0 to 255. And my top raster is going to be my bathymetric dataset, and I'm going to say the color map is the previous color map file we saved. Sorry, the bottom one is going to be solid, so it's going to have a value of 255, and the top one will have 50% transparency using a value of 128. I want to render this at the full resolution. So my output resolution is going to be listed as 0. That implies to use the highest resolution of either of those datasets to render it to. And I'm going to choose to render it to a PNG file, and I'm going to call it rendering with hillshade.png. All right, let's have that go ahead. So I've just created this rendering with hillshade PNG. Let's have a look what it looks like. Beautiful. So now I have my hillshade blended with the bathymetric color map that I had applied to the top. So that's the blend tool. The other thing you may have noticed is that the process information window that used to be up in the top right hand corner here has now moved and is docked to the bottom below the raster workflow and help tabs. We moved it because it was just a little bit annoying sitting at the top here. So now it sits at the bottom, and you'll also notice that it's displaying a lot more information about what's happening. So now you get a timestamp for the progress information that's displayed. You get a list of what function within the ramp libraries has posted that progress update information. And you'll also will have noticed that there's a progress bar at the bottom that shows the progress of a particular function or method call as it's progressing. So that's a progress bar that sort of chugs along at the bottom there. So we've done a little bit of work on standardizing when certain information is displayed in the progress status. And we've also now reporting the full stack of error information when an error is thrown. The other small change has been to what we call hints. So I'm going to choose as an example the let's choose the seg-y factory. And now you'll notice that when I put my cursor over one of the property values in the method, it can provide a tooltip text. So in this case, it's saying the end sample -1 indicates that you should read to the maximum extent of the trace. Previously, we had a separate property that would say help :end sample and then provide that information. But where there are hints available for a particular property, these now display when you move the cursor over that property value box as a tooltip. The other thing we've changed in many of the factories is the naming convention of the methods and their descriptions. These were a little bit confusing before, so now they've been made to be a little bit more obvious as to what the intent of the method actually is. So, for example, in the seg-y factories, we have report the content of a seg-y file, import a seg-y file as a raster, or import a seg-y file as a series of rasters, etc. So the descriptions should tell you a lot more about what that method does, whereas previously that was a little bit confusing. The other usability change we've made to the calculators. So if I open the tabular data calculator, you'll notice now that the function part of the calculator uses syntax highlighting. It just makes it easier to read the function. Also, what's changed is when I choose a file now, you'll notice that it's automatically generated the arguments to the function for you to use. So you can start coding with those variable names and variables straight away in your function. A similar things happen with the raster calculator. In this example, I'm going to choose, let's call this one my Bathy dataset, a kernel size of 0, and I'm going to, for argument's sake, choose the hillshade. We're going to call it HS, and I'm going to use a kernel size of 3. Now that I've done this, you'll notice again that the arguments to the calculator method have been automatically defined in here, so you don't have to do it yourself. We've made some changes to, excuse me, to the raster math processor. Previously, each of the math functions or methods would only update the contents of the raster that you provide. Now they actually generate a completely new raster. So that's a little bit of a change that for some of you might have to get used to, particularly if you have workflows that were based on the assumption that the input raster was modified directly by the method. And the last major change that I'd like to talk about is the introduction of a new reader, and that is the ramp binary grid reader. This replaces what was previously referred to as the ramp binary RLE, or run length encoded grid file. That format never particularly worked that well, and so we've replaced it with the ramp binary grid, which uses LZW or gzip compression to compress the raster data. So this works a lot better, and it's considerably faster than what was previously implemented. So this may be a good option if you want to work with a simple binary grid that you want to compress. One of your options may be to use the ramp binary grid format. So those are all the major changes that have been made in this particular release of ramp. I hope you find this video useful.